Hi, this is Jonathan Garner. This series is an introduction to physics, calculus-based. It's designed for people who may not know calculus or even algebra. In this section, we're going to discuss what physics is all about and some of the philosophy behind physics. You might have heard about physics. You might have heard it as a hard science versus the other so-called soft sciences. What that means is that physics, like chemistry and similar fields, relies upon repeatable experiments and logic rather than supposition or interpretation. The soft sciences include things like economics, sociology, and psychology, where it's simply too difficult to control all the variables involved. Since it is practically impossible to perform repeatable experiments in those fields, people who study those fields must rely on intuition and subjective conclusions. Whereas chemistry studies the interaction of matter with itself, especially the chemical changes that occur when some sort of reaction occurs, physics is concerned with the entire natural world around us. From the biggest galaxy to the tiniest particle, physics covers it all. In a way, chemistry is a subset of physics, albeit a very, very special subset that deals with an entirely different set of rules. There we go. If you want to understand what physics is, you also have to understand where it came from. Anciently, and even today, there's something called a natural philosopher, natural philosophy. These are the ancestors, intellectually speaking, of modern physics. They struggled to understand nature and tried to use logic and reason to predict behavior. Although they were very intelligent and well respected, they were not able to do a very good job of describing nature. And the reason for this was simple. They spent a lot of time thinking and not enough time experimenting. It was the astronomers during the Renaissance in the 1500s, people like Galileo and Copernicus, who started the practice of carefully documenting their observations, building theories, and testing those theories. It wasn't long before they were able to predict the motion of planets to a high degree of accuracy. However, most of their explanation of why things moved the way they did was God said so. Perhaps they felt they were unlocking some secrets of God's mind, or perhaps they were treating the planets and stars as a sort of universal clock that could be used to predict the future. Regardless, their attention to detail started a pattern that set in motion subsequent events. It was René Descartes in 1600s who is credited with the foundation of the philosophy that forms the basis of physics. He reasoned that the universe was merely a mechanical device, a machine that that had predictable behavior based on a set of logical laws. He removed from the universe the problem of God and consciousness and free will. You can imagine why this is important if you put yourself in the mindset of an early Christian or even a Greek citizen. To these people, God or the gods were everywhere. All unexplained behavior could simply be attributed to their interaction with nature in the form of a miracle. The idea that you could test nature and get back predictable and consistent results was foreign to them. René Descartes changed that kind of thinking and paved the way for the next step in history. Isaac Newton wrote the Principia Mathematica in the 1700s, a groundbreaking work that not only introduced the fundamental concepts of calculus, but also introduced the laws of motion that bear his name. For the first time, there was a mathematical model that not only predicted the motion of the planets, but of rocks and baseballs, feathers, and everything else. Using these laws and these laws alone, a tremendous amount of understanding of nature can be achieved. To understand how significant this was, it wasn't until the late 1800s and early 1900s that people found out that Newton's laws were not complete, or rather, incorrect in very specific ways. Just like Newton was willing to throw away all the work of previous natural philosophers, modern physicists threw away his work and looked for new theories to explain these strange new behaviors. Modern physics has seen an explosion in our understanding of physics. The 1800s saw the capstone being placed on the theories of thermodynamics and electromagnetism. The resounding conclusion of electromagnetism, that electricity and magnetism were really different manifestations of the same things, and really the foundation of all light and matter, led physicists on a chase for the grand unifying theory, or GUT. The early 1900s saw the introduction of quantum mechanics and subsequently quantum field theory. About the same time, Einstein introduced his special and general theory of relativity, which literally rewrote our understanding of how space itself is structured. Today, we are struggling to find the grand unification theory that will integrate quantum mechanics and relativity. Every step we take forward seems to take us a little further back, as the universe seems to have a lot to say to us before revealing the grand secret behind everything. There are a lot of different ideas about what the philosophy behind physics is. And here's my take on it, and other people have different ideas, of course. So I start with the assumption that there is the natural world that I call we refer to as the universe. The universe encompasses everything we can see, feel, and interact with. Inside this universe, things are constantly happening, things we call phenomena. Keep in mind, the universe is an assumption. We simply cannot prove that anything exists at all. You might want to talk to a philosopher about what's real. Or as Descartes put it, I think, therefore I am, meaning that the only thing he knows that actually exists is his thoughts, or rather the thinker of those thoughts, his consciousness. The universe is governed by logical rules we call laws, or rather, all behavior can be categorized such that it is described by one law or another. These two statements are equivalent. Some people, they argue about which way it should go, but honestly, they're both the same. All phenomena in the universe must conform with these laws, otherwise it would not be a law. These laws are logical, meaning we can apply logic to them and understand them, and they do not contradict themselves. We don't know that these laws are this way, but we are going to assume so, otherwise we really have no place to begin to understand these laws. The next assumption is that we have the capacity to understand these laws. This is an important idea, and I think one that keeps a lot of people from studying physics. If you think that these laws are too difficult for you to understand, you'll never try to understand them. I recommend accepting the fact that your brain works the same way Einstein's brain works, and that we are just as capable of understanding what he understood. Granted, it takes a lot of work and learning to get to where Einstein was, but it can be done by pretty much anyone. I want to point out that part of Einstein's success was that he thought he was not as smart as everybody else. He spent a lot of time carefully thinking about every aspect of things before assuming he understood anything about it at all. The next assumption after that is that most or even all the laws we have an idea of in our head are probably wrong. Just because we have an idea doesn't make it automatically correct. We must consider the idea that perhaps we are wrong about things. I like to express things like this. Suppose you know 100 things, but you're only 99% certain of each of them. How certain are you that all the things you know are right? The answer may surprise you. You should only be 37% sure that everything you know is right. The more things you claim to know, the less likely you are to be right about everything. The final assumption is that we can perform experiments to compare our understanding of the universe with the universe itself. Here, we can tell if our ideas are right or wrong. But really, we can never ever prove an idea is absolutely correct, short of observing all phenomena in the universe. What we can do, however, is show that an idea is wrong by observing phenomena which contradicts the idea, which is sometimes something physics take great pleasure in doing. It's when we see something that surprises us that we get excited because we are on the edge of learning something new. I should add that that's one of the reasons why the Higgs boson is so exciting. It's literally in the last place that we looked for it. And I think it's appropriate to point out a few things about religion here. The people who pioneered physics were almost universally deeply devout and religious. To hear them speak about their work, you would think it was a religious, not a scientific pursuit. Their great faith in their religion led them to believe that the universe would conform to their religion, and they were ready to find out how wrong they were. My point is this: physics and religion is not mutually exclusive, and we shouldn't let people tell us it is. Those who have beliefs or ideas should approach physics with the same humility, no matter where those ideas come from. That is, we must assume that we are wrong about things, and that the universe has something to tell us. Physics done this way leads to no controversy within your religion. Finally, I want to talk about the word know. Physicists don't like to use this word. That is because the only thing we know is the things which we directly observe, or rather, in the words of Socrates, butchered to suit my point, the only thing we know is that we know nothing. The physicists are ready and willing to abandon all the theories they have learned and replace them with something better. Don't build an emotional attachment to the theories you learn about in physics. Don't suppose that just because it is taught, it is right. We're going to talk about a lot of theories that simply don't work, and we're going to see why people like them and why they ended up being wrong. What about math? What about math? Physics uses a lot of math, and oftentimes people confuse the two subjects with each other. Sometimes in cartoons you'll see a physicist in front of the board doing a bunch of math equations as if that's doing physics. However, as you'll see, math is merely a tool. It's one of many in the toolbox of the physicist. When I introduce math topics to you, I'm going to do it in a much more practical way, not the comprehensive and logical way that mathematicians teach math concepts. Physicists love mathematicians, but honestly, physicists are merely interested in using their results to further our understanding of the universe. If you want to do physics well, you need to learn to do math well. I am not going to teach math well, so you can't really look to me to be a good math teacher. If you want to learn math well, you need to go listen to a mathematician. But don't confuse what mathematicians do with what physicists do. They're completely different. And finally, when you learn some math from a physicist, don't go around pretending you understand it. You really don't. We're giving you a Cliff Notes version of the math, something that can be used to get the job done. And if you demonstrate your mad skills in math to a real mathematician, they're going to get depressed and wonder if there's any hope for the future of math. Math is a field to be respected. Physics uses math like a tool. So thanks for watching. I hope this was useful. Subscribe to my channel to get updates. Click the like button and leave a comment to show your appreciation. If I get something wrong, if you have questions, leave a comment and I'll respond. Bye-bye.